A very good day, students. I welcome you for the continuation of the lecture series on material science. In this particular series, we'll be discussing about the testing of materials. So in the previous three lectures, we discussed about the testing of tensile test and compressive strength, tensile strength as well as compressive strength. It can be measured using the universal tensile testing machine or UTM. So now we'll move on to the next property of the material, which is hardness. So hardness, as you can see in the definition, is the ability of the material to withstand indentation or scratches. So mostly what we do is we confuse hardness with strength. So strength is a different property than hardness. Strength may be tensile strength, compressive strength, bending strength, shear strength. So these things are called as strength. So if it's a tensile strength, if the material has tensile strength, then it will have resistance to pulling, or it will be able to withstand more pulling. Generally, ductile materials tend to have tensile as well as compressive strength. So that is strength. It is different than hardness. So hardness is the ability to withstand indentation or scratches. It's an inherent property which enables the material to withstand scratches, predominantly scratches. So diamond is a hardest material. So if you compare steel and cast iron is more hard than steel, but it does not mean that cast iron has more strength than steel. We would normally confuse between hardness and strength. That's why I'm saying these examples, because a hard material doesn't mean that it is high strength material. So as we discussed about tensile and compressive strength, I said cast iron is a hard material. But when it is subjected to tensile or compressive load, it will fail dramatically when compared to steel. Hence, hardness cannot be equated to strength. So hardness is the ability to withstand scratches. Similarly, high strength materials do not possess high hardness. Hardness can be incorporated in a material by using some secondary operations like hardening process, case hardening, cyaniding, nitriding, quenching. So these are some of the process through which hardness of a material can be improved. Mostly it's a surface related property. So how we test the hardness of a material? That is what we'll be covering in this particular lecture series. So since hardness is the ability to withstand indentation, we can test the hardness of material by making indentation. So imagine you have to test the hardness of a gear. So gears need to be hard because they are subjected to constant movements, as well as they are in contact with one another because it's having surface contact with another gear. So the surface of the gear must be hard in order to withstand the wear and tear. So if you need a material to withstand a wear, then it should be hard. So a tool should be hard than the workpiece. Then only the tool will withstand the wear and tear. Similarly, both gears, when they are meshing together, they should be hard so that there is no wear and tear among the gear parts. So to test those hardness, there are different types of testing methods available. Similarly, Brinell hardness testing machine, Vickers hardness testing machine, and as well as Rockwell hardness testing. So these are three major macro hardness testing methods. Similarly, there are micro hardness testing methods also. So depending upon the size of the workpiece, if it is a larger workpiece, you can go for macro hardness testing. If it is a small micro device, you can go for micro hardness testing also. So this is just an introduction to the hardness testing process. So we can measure the hardness by making indentation. So that is regarding this lecture video. Now, in the next video, we will discuss about the various testing methods, hardness testing methods. Thank you.